Right. So what I've done is I've adjusted the software. This is a GWiz thing. I've adjusted the software now to add in the last cell, because this is for the GWiz. I'll show the actual hardware, but this is the GWiz. And so what you can see is obviously we've got the first cells, the first 3 cells, yeah, 4 volts, 3.3, 3.967, whatever, 697, 399, yeah, and then the last cell. So how I got this one was I actually measured the voltage of the next to last cell and added that into the software. Okay, 4795. That was the voltage at that point. So I can subtract that. In other words, pretend that I've read it. I can subtract that, and that gives me the difference to the actual voltage that's read here. So I can actually see the voltage of the cell, which is 399. 398, 399. Okay. Now I had to put in an adjustment because the first cell was reading 4.04. Right, so there's an offset on the ADC which I've added in here, yeah, because the actual cell voltage is 4.0. So I put in an adjustment here for the ADC reading. Why it's there I don't know, but I'll just put in the adjustment. So all these are reading pretty much, that's 4.0, 3.97, 3.99 and 3.98, and I'm presuming these ones are probably going to be like 4.01 or something. Well, they're not, there's nothing attached, but that's the sort of thing we're going to be expecting. Yeah. And because I'd already done the test on this one, I added it in the circuit basically. It's already on the board essentially. This is the other experiment, the one that I've got going here, which I'm now putting on charge. It's still taking an amp for some reason. The charge is still taking an amp. Sorry. I don't know why. Deal with that afterwards. And we've still got the same circuit. I've replicated this circuit downstairs in the GWiz so as to get the readings for those first 3. And I've measured the I measured the ADC offset, but I've just used the same calculation here, so this might actually be inaccurate. Don't know. It's the same components, but there's a tolerance value on the components, so it might have changed. Right, and then this one was already on the board, this one, so it was as I originally measured it. That's the voltage, as I say, on the number 12 cell, 13 being the last one. And what have I got here? What's this? Oh yes. So this value here is the difference across the 2 Zeners, right? The 2 Zeners give us a voltage difference of that. Okay, so it's two decimal places. This one's 2 decimal places. So now we can go downstairs and see the actual experiment. Yeah. So we've got the actual experiment, and I think, yeah, the bare wires, we've done that one, haven't we? So this is the one that's measuring the top cell, which you can see. Let me just put a light on so it fills in the dark. So this is the top cell here. So what I did is I measured the voltage at this point relative to the ground over here, and it gave me a voltage. Okay, now to get the calibration of the ADC, I measured the first cell, which you can see here. It's exactly 4 volts, but the ADC is showing it as 4.04 after the calculation. And so I put that adjustment in. That's the one that you can see. So what I'm going to do now is measure the cell difference. 3.99. And this one, I think. Okay. Oops. There we go. 3.99. So there's a slight bit out because I think one says 3.97 or something. Okay, and then we can measure. So what I'll need to measure here, I'll need to measure the voltage at the cell, but then I need the voltage from the previous, don't I? So here. There we go. Normally this is calculated. 3.99. Right, so it's actually showing reasonably accurate stuff here, isn't it? Let me just do sorry, I'm just going to do and put a tail on here so we can actually see it on here as well. Yeah, there we go. Oh, shut up. So you can see here, these are the voltage readings. Yeah, there's, oh sorry, let me turn the torch off. So you can see there, obviously cell 0 is at 4 volts direct reading, so that's not a surprise. The next one is 397, and then the next one is 399. Okay, so probably this one here, I need to remeasure this to get the calibration of this. Yeah, because there's obviously, it's slightly out, although it does change to 398. There's going to be a slight inaccuracy there. Not much, obviously. It's usable. This one's showing 39 something or other, so I've obviously got I guess a different issue there, because it's 399. Look, see? Put the light on that one. 399 or 4.0 if you round it up, whereas that is actually showing 394. You know, pretty close, obviously, but I want the accuracy. Yeah. Yeah. And then obviously you can see the ones that are here, these are all not connected. There's no connections. So not today, but the task is obviously to create circuits for connecting the rest of them. The other what is that, 10? 9 cells. Yeah. We need the voltages for, and then we have the full set. If we have the full set, yeah. Yes. But that's the experiment. You can see all the cells are actually, it is actually reasonably well balanced from this circuit. It looks like that to me. So we just need the software to reflect that, essentially, don't we? Yeah. I don't really like using LEDs, so I actually, you can get 4 volt Zeners, and obviously it's going to be a 4 volt ladder, so it'd be quite easy for me to get 4 volts. The trouble is Zeners take more power. You know, and obviously it's a measuring thing, so we don't really want to be discharging a battery just to see what its charge is. That's not really right. So I don't know, and so I'm erring on the side of diode sequences. The other thing I'm looking at is you can use an LM317 because it has a calibrated voltage of 1.25, and the actual voltage that's taken by the adjust pin is microamps, but it does need a certain amount of current just to get the accurate voltage. You see, like I think it's roughly the same as a Zener, like 20 milliamps. So whilst it would probably be more accurate than a Zener, and you'd obviously need a chain of them, so it would be a lot more expensive, relatively speaking. You know, if you want to, you know, do a 50 volt chain, you'd need a load of them. Or you could use one and put the adjustment on it, the adjuster on it. Something like that. If you only need one for each one, then that's a much better scenario, really. You've got 13 then, haven't you? Or 12, because you don't need the first one. Right? You could get away with the second one as well by just using a potential divider, frankly. You know, because using a potential divider to measure up to 12 volts is probably more accurate than using this. The reason why I'm actually using a miniature primitive analog computer instead to subtract the value is because then it gives you more accuracy at the cell itself. You've got a greater amount of range translated to the ADC pin, which means you've got more accuracy because of the range. However, if you're losing accuracy because of this inaccurate method of subtracting, then you know, it's questionable. And using a couple of resistors in a potential divider is actually reasonably accurate, because yeah, there's the other experiment doing the charge. You can see it's held quite happily at 104 volts for the 26 cells, which is 4 volts a cell, and it's currently drawing about an amp, isn't it? Oh no, it's not an amp. It's drawing about 10 milliamps from the power pack to maintain it. Yeah. Which is going to be, I don't know. They do have a certain amount of self-discharge, so that's probably just the self-discharge, a watt. bearing in mind that this pack here is in the region of 300 watt hours, so to draw a watt is pathetic, you know. No, I think it's 3 kilowatt hours, isn't it? Or perhaps 5, something in the region of 5,000 watt hours, and we're drawing a watt. It's drawing a watt to charge. So the self-discharge is obviously very low. Yep. Yeah, basically, if the self-discharge is about a watt, and you've got 5,000 watt hours, then for it to discharge, in theory, you're talking about 5,000 hours. Okay, now 2 days is 48 hours. Let's just say it's roughly 50, which means it would be 100 days. 100 days is 3 months. So that would self-discharge in 3 months. Yeah, apparently. And that's with rough and inaccurate calculations. And it is just possible. I haven't got anything else connected. I was going to say it is just possible it's because I've got something else connected to it, but I haven't. Yeah, so I don't know. And obviously we need to replicate that 3 times because we've got 3 packs. Yes, we would. Anyway. Yep. Let's just take this off. Yeah. Good.